Welcome Algebra 1B students to our first asynchronous session. I'm Mr. Dilly. There's a picture of me. If you want to see further pictures of me, you can read your welcome messages. In your welcome messages, I wanted to let you know that I am your greatest resource in your success in this class. Before you reach out to friends, family members, websites like answers.com, which may or may not get you the answers, reach out to me. If you contact me and I help you get the answer, that's not cheating. That's called being a good student. All right, so let's go ahead and move on to this unit's topic. Take a look at this picture. I think we all know who that is. Can anyone spot the parabola? I'll give you a moment to do that. Well, there's one parabola right there. I see a couple more. Yeah, the little V symbols in his hands make like little parabolas. All right, since 3 of the 4 topics in this unit had something to do with quadratics or involved quadratics, I thought that would be a good topic for today's asynchronous session. So what exactly is a quadratic? A quadratic equation is a polynomial of degree 2, meaning it has some variable raised to the second power. In this example here, we can see that x is being raised to the second power right here. The values a, b, and c are going to be numbers. They can be whole numbers, they can be negative integers, they can be square roots, they could be decimals, fractions. They're just some number, all right? But there has to be an x squared term. All right, so that's why the a term right there cannot equal 0, because if it equaled 0, then we wouldn't have a quadratic anymore. We would just have a bx plus c, which is a linear equation. All right? When we have a quadratic in this form, so we have it set equal to 0, ax squared plus bx equals 0, we call that the standard form. So all in your lessons, when you hear them talking about getting into the standard form, that's what they mean. We can't have it equal to some other number over here other than 0, or have other x's over here. All right, now the graph of a quadratic is called a parabola. All right, below I'm going to have some examples of quadratics. All right, so there's an example of a quadratic. There's another example of a quadratic, and here's the third example. As you can see, they can open up or down, and they can even open left or right, but we won't deal with those right now. All right, they can be fat, or skinny. That all depends on the values for a that we have in the quadratic equation. But they'll always have this same basic shape. They'll have one turn, and they'll kind of look like little U's. All right, so when we're dealing with a parabola, there's always a few important points that we always talk about in our math classes. All right, these 2 points right here have a few different names. We call them roots, zeros, solutions, x-intercepts. They're all the same thing. They are those points. They are where the parabola crosses the x-axis. So when we're using the quadratic formula, or you're factoring later on, and they ask you to find the solution of this quadratic, that is really what they're asking you to find, where this parabola crosses the x-axis. The other important point of interest is this point down here at the bottom. All right, we call that the vertex. All right, it's where the graph turns. It's either always the lowest point on the parabola, like in this case, or the highest point on the parabola if the parabola is opening down. All right, an x-intercept solution root 0, right, is the x-coordinate of where the graph crosses the x-axis. And a parabola can have 0, 1, or 2 x-intercepts, as demonstrated by these examples below. Here in this first one on the left, you'll see that we have a graph that's crossing the x-axis twice. So it has 2 solutions, or 2 x-intercepts. This one in the middle here just touches the x-axis in one spot, so it only has 1 solution, or 1 x-intercept. And here's an example of a parabola that lies entirely above the x-axis and it never crosses it. So it has zero x-intercepts, or zero solutions. In one of your lessons, they talk about the discriminant. All right, the discriminant is the part underneath the quadratic formula, underneath the radical b squared minus 4ac, and it indicates, the value of that indicates if you have either two solutions, one solution, or zero real solutions, but we'll talk more about that later. Here on the left, we can see we have a parabola opening up or upward. When a parabola opens up, it indicates that the value of a, when we have the quadratic in standard form, is positive. All right. If a parabola opens down like the parabola on the right, then we know that a is a negative value. Quick question. What if a is 0? I'll give you a second to think about that. If you said a can't be 0, congratulations, you're right. Remember, a cannot equal 0. Otherwise, we don't have a quadratic equation. All right. Now, I want you to take a look over here at the equation y equals x squared. This is a quadratic. In fact, it's the simplest form of a quadratic, which we call a parent function. Can you tell me what the value of a is? That's right. Although we don't see a number there, if you said 1, then you're correct. In this equation on the left, the value of the a value is a positive 1. It opens up. What's the value of a for the equation y equals negative x squared? If you said negative 1, then you are correct. We don't see the ones written there, but when they're not there, they're implied, right? Same thing if you have an exponent that's not there, then it's implied that it's a 1. All right, so question. I'll give you a few seconds to think about it. Does this parabola open upward or downward? That's right, it opens upward. So does that mean that the value of a is positive or negative? If you said positive, congratulations. Let's try another one. In this case, I want you to identify the vertex. Remember, the vertex is the point at which the parabola turns. It's either the highest point or the lowest point. And since we have a coordinate plane, we write a point in the form, as an ordered pair in the form x comma y. So we want to list the x coordinate and then the y coordinate. So in this case, we get that the parabola opens down, so that we say the vertex up here is the highest point. We call that point the maximum. That maximum, or vertex in this case, is located at the point 3, 6. Right? We always list the x coordinate first, then the y. All right, so find the coordinate of the vertex in this example. As an ordered pair, remember, we list the x first, then the y. All right, we know the parabola is opening upward. The vertex is a lowest point, or a minimum. Right, we call the lowest point a minimum. And that minimum, or vertex, is located in this case at -4, -3. We also had a lesson that talked about the axis of symmetry. Right? The axis of symmetry is just a line that divides the parabola into two mirror images. You've heard the term symmetric used before. You know, in geometry, it's a line that separates an image so that it's the same on the left and right, or top and bottom. Many things in nature are symmetric. For example, the wings of a butterfly, or to a certain extent, even the human face, right? If you run a line down the center, the left side pretty much looks like the right side. All right, so in this case, think about where we could draw a line so that if I folded the image over that line, it would match right on top. All right, the mirror image. this case, you can see that that line would run right through the middle of this parabola through the vertex. All right? So we call that in algebra here the axis of symmetry. So when you hear them talking about the axis of symmetry, that's all they're talking about, where it cuts it in half. So we say that that happens at 4. Sometimes you'll see it worded differently, where they're asking you to find the equation of the axis of symmetry. Well, as we saw in the last example, the axis of symmetry is a vertical line like this, right? Vertical lines have the equation x equals some number, all right? So take a moment to figure out the equation of the axis of symmetry for this line. It's simply x equals -2. Fairly simple, easier than you thought. Let's try it again. Find the equation for the axis of symmetry for this parabola. Alright, so as many of you probably have the right answer, it is x equals 3. Now we're going to talk about the x-intercepts. Remember, intercept means where something crosses or touches. When a football player intercepts a pass, he's getting in the path of the ball and coming in contact with the ball. So here we're looking for where the graph is coming in contact with the x-axis, right here in this case, and here. Alright, so we say that the x-intercepts for this parabola are at -5 and +5. That's all we're looking for, those x-coordinates, where it crosses. Right, and when you have a picture, a graph, this is real simple. You can just look at it. Even if you have more complicated parabolas where maybe it crosses in between a number, right? If you're using a graphing calculator, you can just scroll over with your arrow and it will show you those values. Alright, so let's take a look at this parabola. Alright, so what is the x-intercept, or remember, solution, or zeros, or root? That's right, you can see that that happens roughly right here at 4. What are the x-intercepts for this parabola? Asking yourself, where does it cross the x-axis? In this case, we have 0 x-intercepts, or we say none, because the entire parabola lies above the x-axis. Remember, we'll talk about this a little bit later, that would be indicated by the discriminant as a negative number in the quadratic formula. Alright, so some practice. Does this parabola open up or down? Right, clearly it opens up. Find the equation of the axis of symmetry. So remember, it's x equals some number. That's the equation of a vertical line. There it is. So we got the x is equal to 4. Find the x-intercepts. Remember, so the x-intercepts are here and here. So they are at 1 and 7 in this case. And finally, let's find the coordinate of the vertex. Remember, we write that as an ordered pair. Always the x-coordinate first, then the y. So here's the vertex I'm looking at right here, and the x-coordinate there is at 4. And the y value associated with that is at -7. So we'll say that it's at 4, -7. One more try. I'm going to give you a few minutes to do this one. Alright, as we can clearly see, the parabola opens downward. The vertex here happens to be then a maximum. It's the highest point on the graph. The axis of symmetry is at x equals -2. That's the equation. The x-intercepts, well, there they are right there. They're both at -5 and 1. And the coordinates of the vertex. Well, there's the vertex right there. And we can see that as an ordered pair, we list the x first, -2. The y coordinate that goes with that is 6. Alright, so what if we don't have a graph? What if we just have the equation? Alright? The first thing we have to make sure is that the equation is in standard form. Remember, we want ax squared plus bx plus c to equal 0. When they write it in terms of a graph, yes, they'll have the y coordinate listed. Alright, so the steps for finding the vertex algebraically are to get the equation into standard form if it's not already into standard form. Alright, then we're going to identify the values for A, B, and C. Then we're going to find the x value of the vertex by using this equation. X is equal to -b divided by 2a. And that's just going to be a number, right? That's going to be that x value of the vertex. But having just one value, the x value of the vertex, doesn't identify the vertex completely, right? Because the vertex is a point. So then we need to plug the x value back into our equation and solve for the y that goes with it. So let's do an example. Find the vertex for the parabola y equals -x squared minus 10x minus 25. Well, first we ask ourselves, is this equation in standard form? And in this case, yes it is. We don't have this equaling, we don't have anything else over here with a y. We don't have any other numbers or any other x's over on the other side of the equal sign, so it is in standard form. So we can go ahead and identify our A, our B, and our C. So remember from the example earlier, when you don't see a number there, right, there's an implied 1. And we have a negative in front of this x squared, so the A term is -1. Our B, as we can see, is -10. And our C is -25. Always associate the sign to the left with the sign of that number. Alright, now we're going to use the equation x equals -b divided by 2 times a to find the x value. So let's go ahead and do that. So you can see this negative is always here in the equation. And then in parentheses, I plugged in our b value, which is -10. So we have a negative minus 10 divided by 2 times the a value, which is -1. I see a lot of students, the mistake I see often is that when they're plugging in the values for a and b, they're including the x. Remember, there is no more x's. The a, b, and c's are just numbers. All right, so now we're going to go ahead and simplify this. The opposite of -10, or you can think of it as -1 times -10, is +10. 2 times -1 is -2. So we have 10 divided by -2, which is -5. So we know now that the x-coordinate of the vertex is at -5, but we don't know what the y value is. Right, so now we need to plug this value for x back into our equation and then figure out the y that's associated with it. Right, so let's plug it in. Right, so here's the negative from right here, this negative in front of the x squared. And then we plug in our -5 squared minus 10 times -5 minus 25. And then finally, now we just use the order of operations to simplify this and come up with our solution. So the first thing I would do here is square the -5. And -5 squared, or -5 times -5, is +25. But then I apply this negative to it, so we get -25. I think of this as being negative 10. So negative 10 times negative 5 is positive 50. And then finally we have this negative 25 at the end. Now I can just add and subtract from left to right. So then negative 25 plus 50 is positive 25, and 25 minus 25 is 0. Alright, so that in this case, the x-coordinate of the vertex is at negative 5, and the y value of the vertex is at 0. So we write our answer as the ordered pair, negative 5, comma 0. Alright, so I'm going to let you practice. Go ahead and pause the video here and then work out this one by using the equation x equals negative b over 2a. Alright, so we identify our values for a, in this case, which is 1, b, which is equal to negative 6, and c, which is equal to 9. So we're going to go ahead and plug in our b and a into negative b over 2a. So then here's the negative that's always in front of the b, and then b happens to be negative 6. Then we get 2 times a, which again is in this case 1. So the opposite of negative 6 is positive 6. And 2 times 1 is 2. And then we get that 6 divided by 2 is 3. So now we're going to go ahead and plug that value back into our equation for x and solve for y. Alright, so using the order of operations again, we're going to square first and get that 3 squared is 9. Negative 6 times 3 is negative 18. Then we have a plus 9 at the end of this equation. 9 minus 18 is negative 9, plus 9 is 0. In this, we just happen to have 2 different examples where the y turned out to be 0. That is just a coincidence. The y value is not always going to be 0, because remember the vertex can be anywhere on the coordinate plane. Alright, so now we've looked at a graph and how to identify the x-intercepts, but now once again we're going to go ahead and see how to find the x-intercepts, or the roots, or the solutions, or the zeros. Remember, they all mean the same thing of a quadratic equation if we don't have the graph. Alright? And the way that we're going to do that today is with the quadratic formula. There are 3 different methods that you're going to learn about in the course of your careers as high school math people, right? And this is one of them. This is the one of them that always works. If you had to know just one way to do it, and you only knew one way to do it, this is the way that I would have you learn, because you can learn, you can solve every problem with it, even though in some cases it would take longer. Anyway, you have a question on one of your discussion questions that ask you for a way to remember the quadratic formula. So I'm going to go ahead and play a short video for you, which is what I remember learning in school for a quick little way to remember the quadratic formula.
The quadratic formula's negative b plus or minus the square root of b squared minus 4ac all over 2a.
Alright, so once again, there's the quadratic formula. Alright, and if any of you are really interested on where that came from and how to derive it, you can come to me and we can do a one-on-one session. I can show you where that comes from. But for now, all you have to know is that once you have a quadratic in standard form and you identify the a, b, and c, you can just plug it into this equation and then follow the order of operations to get your solutions. Notice the part underneath the radical. the b squared minus 4ac. We call that the discriminant. As I mentioned earlier, right, it indicates how many real solutions there are to the quadratic. By solutions, remember what I'm referring to. I'm referring to where the parabola crosses the x-axis. And as we saw, that can happen either twice, just once where it touches it, or 0 times, right, when the parabola lies entirely above or below. If this discriminant is a positive number, any positive number, you're always going to get 2 real solutions. That's the picture where it crosses twice. If the discriminant, this number underneath the radical, is equal to 0, that's when you get 1 real solution. And then finally, if this number underneath the radical is a negative number, that's when you get 0 real solutions. That happens because we can't take the square root of a negative number and get a real number, right? If I asked you what the square root of negative 25 was, we don't have a real answer because 5 times 5 is positive 25, not negative 25. And negative 5 times negative 5 is also positive 25. So I can't take a number and multiply it by its own self and come up with a negative number. All right, so let's do an example of using the quadratic formula to find the solutions. Again, we have to get it into standard form, and then we identify what our a, b, and c are. We're going to substitute, which just means, hey, replace those letters in there with the numbers that they are, a, b, and c, into the quadratic formula. Then we'll follow the order of operations to solve for x. Just a quick check for understanding. How many solutions are possible when we solve for using the quadratic formula? All right, you should have said either 0, 1, or 2. All right, so let's solve this quadratic using the quadratic formula. We have that 2x squared plus 2x minus 12 equals 0. I'm going to check to see that this is in standard form. And yes, it is in standard form. I have a quadratic that is equal to 0. All right, so let's find out what a, b, and c are. All right, we can see that here's a, it's equal to 2. B in this case is also equal to 2, and c is equal to negative 12. We're going to plug those into the quadratic formula, and then we're going to solve. All right, so here you can see I've plugged in a and b and c into the formula here. It'll be easier if you go ahead and just put parentheses around all the numbers that you're plugging in. All right, so this negative is here, and then I plug in the b, which is positive 2 in this case. And plus or minus b, which was 2. This 4 is always here. And then a is 2, and c was negative 12. So when I begin to work this, I'm going to work underneath the radical first. You know, by order of operations says that's where I should start. I'm going to start with squaring because we have to square before we do multiply and divide. All right, so I get 2 squared, and that's how I came up with 4 here. And in this next step, that's all I did, was just square that term. All right, now I went ahead and I multiplied the rest out, the 4ac underneath the radical. And watch for a mistake here. When I first started learning this, this is the mistake that I made, and it's a mistake I see made for most students. They think that because there's a minus right here in between the b squared and the minus 4ac that you just always write a minus there. All right, that minus applies to the 4. Think of that 4 as being a negative 4. All right, so in this case we have negative 4 times 2, which is negative 8. But then we're going to take negative 8 and multiply it by negative 12, which is positive 96. So that's why I write plus 96 here, not minus. Okay, so be careful of that when you're using the quadratic formula. I'm still going to simplify under the square root, so my next term is just to add 4 and 96 to get 100. And then now finally I'm going to take that square root of 100, all right, which is in this case 10, because 10 times 10 is 100. If it wasn't a perfect square, you know, like 100 or 81 or 36, let's say I had 18 under there, the square root of 18. All right, I would just leave it as the square root of 18 under there for now. Later we'll talk about simplifying radicals and then to make it a little more simpler. All right, so now I have that the answer is -2 plus or minus 10 divided by 4. And this plus or minus here is how we end up getting our two answers in this case. All right, so one time I rewrite the equation letting it be a plus, and the other time I'm going to rewrite the equation letting it be the minus. So let's do the plus first. -2 plus 10 divided by 4. Well, -2 plus 10 is positive 8, and so we have that 8 divided by 4 is 2. So now I have one of the roots, or solutions. But I'm not done. I have to take my turn now letting it be the minus. So that's what this symbol means in the beginning. I know it's not one you see all the time, this plus or minus, right? It's both, one and then the other. So now we have that here is -2 minus 10 divided by 4. All right, -2 minus 10 is -12 divided by 4, which is -3. So we generally write our two answers here is 2 and -3. These little curly Q brackets, these are kind of special little brackets here. All right, they're not the ordered pair brackets. They indicate a set. So, in this case, we're saying, hey, the answer is these two things, 2 and -3. All right, so you try one. First, I want you to identify the A, B, and C. All right, so A is 1, B is -5, and C is -14. And you go ahead and substitute those into the quadratic formula. So do that now. So when you plug your values into the quadratic formula, you should have got this. Notice that we have negative, and then we plugged in our b in parentheses, which in this case was -5. So we have a -5. So remember, begin working underneath the radical. All right, so we get that b squared, or -5 times -5 is +25. Finally, we did -4 times 1, which is -4. And -4 times -14, which is +56. I'm going to continue simplifying under the radical. Notice here that the opposite of -5, or -1 times -5, however you like to think about it, is +5. Then we have plus or minus the square root of 81, which is 9. Your last step should have been to write the two equations, one where we let it be a plus, so 5 plus 9 divided by 2, which is 14 divided by 2, or 7. And then we get that 5 minus 9 divided by 2 is equal to -4 divided by 2, or -2. And we write our final solution as the set of 7 and -2. It doesn't matter which of these you list first. I could have wrote -2, then the 7, because all we're stating is, hey, these are the two roots, the two solutions. Remember, hey, these are the two places where if we had the graph, the picture, that the parabola would cross the x-axis. It would cross at 7 and another time at -2. I want you to take a moment, read over these 5 questions over these 2 slides, and then submit them to me via email or message on your desktop.